Hello everyone. In this video we're going to talk about the measure of variation, and we are going to learn how to compute the range and standard deviation. So far what we have seen measure of center. We have already seen that measure of centers, and I told you there are three of them most commonly used: mean, median, and the third one was mode. We already learned that in the previous video. Now we are learning what are measures of spread. They are also called the measure of variation, or they tell us how much is the spread in our data. As the name tells you, measure of spread or measure of variation or measure of dispersion, right? These are all. They tell us how much is the spread in the data. In order to understand this idea, let me give you an example. Let's say, I hope you have seen the dartboard. Let's say these are the two dartboards. These are the two dartboards, right? And this is the target. This is the target, right? This is me, who has never played this game, and this is a professional player. Right? Look at where my darts are landing. Look at that. And remember, I never played this game in my life. Right? And look at the professional player. The darts. These are the darts who are landing on the board for a professional player. Clearly you can see that I'm not the winner, right? This person is the winner, definitely, right? My darts are away from the target. Why I'm not the winner? Because my darts are landing away from the target. So we are going to say in a statistical term, if we want to give an example in a statistic, we're going to say there is a more spread in this data and there is a less spread in this professional player, right? This data has more spread. You can clearly see, and this has less spread. That's why this person is a winner, right? So measure of spread gives you how much is the spread in your data, right? And there are three most commonly used measure of spread, and these are the first one is the range. The second one is the standard deviation, and the third one is interquartile range. What we are going to do, we are going to cover the first two, the range and the standard deviation, and we are going to cover the interquartile range in a subsequent video. So let's see, what is a range. Range is defined as it's the difference between the maximum value of the data take away the minimum value of the data set. Simple, very simple to compute range. This is the formula to find the range. Take the maximum value, subtract the minimum value, you will get the range. Take an example. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's say this is my data set. Clearly, everybody can see that the minimum value is 1 and the maximum value is 9. So what will be the range in this situation? The range will be 9 minus 1, and that is equal to 8. Right? Simply, if you want to find out the range, it's simply a subtraction problem. Take away the maximum value, take away the minimum value from the maximum one, you will get the range. There are something good about range, there are something good about range, and there are something bad about range, right? What is good about range is it's very easy to compute. Very easy to compute, just a subtraction problem. And but what is bad about range? When we compute a range, only, look at that, only the maximum value and the minimum value take part in the computation, the rest of the data values are doing nothing here. They are not taking part in the computation. For this particular reason, the range is not a preferred measure of variation, right? Only take it, so only maximum and the minimum value take part in the computation, not the rest of the data values don't take part of the computation. For this reason, this is not a preferred measure of variation, right? Only minimum and maximum values take part in the computation, right? So this is something bad about range. Okay, so if this is not a preferred measure, what is the preferred measure? And this will lead us to the standard deviation. So I told you that the range is not a preferred measure because only the maximum and the minimum value take part in the computation. The rest of the value don't take part of the computation. So if range is not a preferred measure, then what is the preferred measure? And the preferred measure is a standard deviation, right? What is the standard deviation? I will explain this now. Let's to understand the standard deviation, we need two data set, right? Let's just see first. Let's say I have 1, 2, and let's say this is 15. Let's say this is the first situation, and the second data set is 5, 6, and 7. Okay, I ask you to pause this video and compute the mean. Clearly, you see clearly the mean for the first one is 6, and the mean for the second one is also 6. Both data sets have the same mean, but clearly you can see this data set, there is a more spread in the data, right? And there is a less spread in the data. There is a more spread in this data, and there is a less spread in this data. The data values are less spread out from the mean in this situation, whereas the data values are more spread from the mean in this data. So what the standard deviation tells you? Standard deviation tells you how far away each value is of the data set from the mean of the data. That's the standard deviation tells you. I repeat, this is very important you understand. Standard deviation tells you how far away each observation is from the mean of the observation on an average. What is the average distance of these observation of each observation of the data set from the mean, right? So the question comes to the mind, okay, we have seen that this data set has a more spread and this data set has a less spread, right? How we are going to compute that spread, right? We want to compute how much is the spread in the data. How much is this? We want to quantify this. Take an example. Let's say I have a fever, God forbid, right? Let's say I have a fever. Then I want to know how much fever I have. What I will do, I will take a thermometer, and the thermometer will tell me, okay, this much is the fever you have. So I have a method, I have a way to determine how much fever, what is my body temperature is, right? In a similar line, there is a spread in the data. We have seen there is a more spread in the data and there is a less spread in this data set. So how are we going to quantify? And this is done by using this formula. So we represent a standard deviation, we represent a sample standard deviation by a symbol S, and that is given by this particular formula, right? This is a summation, and this is xi minus x bar whole square divided by n minus 1 and the whole square root, taken whole square root. That's the formula to compute a sample standard deviation. But that formula this is called the defining formula. There is another formula which is called a computing formula. This formula is called defining formula. Defining formula. Right? Defining formula. This formula helps us in understanding the definition of the standard deviation. But the good thing is that I'm not going to ask you to compute this standard deviation by using this formula. Rather, I'm going to ask you to use Excel. So whenever you are going to when you're asked to compute the standard deviation, you are going to use Microsoft Excel. So Excel is going to be our technology for this particular purpose, and the command for this is you write an equal sign. I will show you in a minute. The command is stdev.s, and then you provide the values within the parentheses. STDEV means give me the standard deviation. .s mean for the sample data. Remember, there is a different formula for a population. Had this been a population data, I would have used a different formula, right? There is, for the population, I have a p here. The standard dev.p for the population and standard dev.s for the sample. How we're going to do that, I will show you now using Microsoft Excel. So here we are in the Excel, and let us suppose I have this data set, right? These are the data values, and I am asked to compute the mean and the standard deviation by using Microsoft Excel. So what I'm going to do, there are several methods we can use. Remember, in Excel, one task can be done in a multiple ways, in a variety of ways. This is not the only way of computing the mean and the standard deviation, but let me tell you the easiest one. So whenever you are about to enter a formula in Microsoft Excel, you start with an equal sign. When you write an equal sign in the cell, this is an indication for the Excel, oh, somebody is about to enter a formula. So you write STD. So do you see Microsoft Excel automatically completes this formula? Is asking, do you want standard deviation for population or do you want standard deviation for the sample? So I say, okay, I want for the sample. You double click that, and now he is asking, okay, give me the number. Give me what are those values for which you want to compute the mean, right? So I'm sorry, I have to compute the mean for that. Why I'm writing standard deviation. So this is formula is average, right? Sorry for that. So I write average here, average, and what I do, he is asking, give me the number for which you want to find the average. These are the numbers for which I want to compute the average. This one, and you close the parentheses. Even there was no need to close the parentheses, and hit the enter, and here's the average comes, right? And now I'm going to compute the standard deviation. Now you write equal stdev.s, right? St, just if I write st, Excel help me what you are interested in. So write stdev.s, double click on that, and now he's asking, give me the values for which you want a computation. This is my range. I click my cursor here, and I press the left mouse button and I drag it downward. In this way the range is copied, and then I close the parentheses and I hit enter. So this is the standard deviation computed for me, 14 point. If we want to round it to a 2 decimal place, it will be 14.2. So the mean of the data set is 5 and the standard deviation is 14.2. That's how you compute the mean and the standard deviation using Microsoft Excel. So this was the one way of computing the mean and the standard deviation for this data set, but this is not the only way. I'll tell you the second method, and this for the second method, what you do, you go to the data, right? When you click on the data, you find a data analysis toolbar. Look at this one I'm talking about. Look at my cursor, data analysis. So you click on the data analysis, and now he is asking, are you interested in the descriptive statistics? Yes, we are interested. By default, this is the first choice. You say, yes, I'm interested. You press OK. Now he is asking, what is the input range? Which means, where is your data set? So I bring my cursor here, press the left mouse button, and I went up to this one. So the range is copied. He's asking group by columns or group by rows. My data is already in the column, so there is no need. Now he's asking, do you need a summary statistics? Yes, just check this box, summary statistics, or do you want this result to be where you want this result to be? So just tell him the way I want the result. Just tell him I want the result here, okay? And you press OK, and you will see the summary statistics. Oh, sorry for that. So something went wrong. Let's see how we're going to do that. You go to the data analysis, this one, just clear that. He's asking, where is your data set? This is my data set. He's asking where you want your input, where you want your output range. You just give the output range where you want the output to come, and just check this box, and let's see what happens. And you see